All right, welcome everybody. We're going to be talking today about sections 2.1 and 2.2. Hey. And these sections are both about working with integers, which I have mentioned, and we've actually done some work with integers already in various ways. So it's going to be a partially review from earlier in the class, but also kind of going a little deeper on certain things as well. So let's remember what the set of integers is. The integers are all the whole numbers and also all the negatives of the whole numbers. So the whole numbers are 0, 1, 2, 3, 4, forever and ever and ever. And then we include in that the negatives, all of those. So we include -1, -2, -3, -4, forever and ever. 0 is neither positive nor negative. It's just 0. So there is no -0. And for a lot of human history, as I mentioned, for a lot of human history, just working with whole numbers was pretty good. But then some mathematicians and probably also some business people were like, well, what if I have 3 cows, but I owe you 6 cows? Then actually I have -3 cows, because once my cows have babies, those belong to you as well, right? So right in this moment, I have the negative number of cows. Or just as a mathematician playing around with addition and subtraction, someone went, what happens if I do 2 minus 4, right? I break out into a new world of numbers. And the integers were really what allowed, in some way, it's what allowed business to develop. And increased our understanding of the world around us. So those are the integers. Decimals, I just want to point out, decimals like 2.8 are not integers. Right? Anything with the numbers after the decimal point is not an integer. Most fractions are not integers. Like 3 divided by 4, not an integer. 7 divided by 2, not an integer. However, and we'll come back to this when we get more into multiplication division, if your fraction can reduce, it could be. Like, what's 4 divided by 2? So that is an integer, right? Because it could be written just as an integer. But most fractions are not integers. As soon as we allow ourselves to start writing as numbers as fractions, we've expanded beyond the integers. I think that using number line is the best way. Oops, my spelling is not so good today. Using number lines to understand integers is a great idea. This comes back to our different representations. of mathematical ideas. Integers, these are numbers here. And the number line is a way to visualize what the integers are. So it's pictures that represent integers. And if we build our integers the same way we built it from our numbers, we would start at 0. And then we would walk to the right. And take equal-sized steps and go on forever and ever. And then the negatives of our whole numbers would go the other way. So they would go left. And now we really have the number line because it is a line that never ends at either end. One reason I think the number line is helpful is when we start talking about what does it mean to be bigger? What does it mean for one integer to be, maybe bigger? That's one word. Or larger, or in particular, greater than. And this greater than, we're going to develop a mathematical symbol for that if you haven't seen it before. Well, is 8 greater than 3? Yeah, that's pretty clear. Is -8 greater than 3?
No.
Right, but the number 8 is bigger, but it's a negative. So greater than does not mean larger. It really just means the larger number is to the right on the number line. That's how we decide whether one number is greater than another. If we put it on the number line, is it to the right? Some examples here. 8 is greater than 3. Can you still see that? Yeah. Because if I draw my number line, and I usually like to center it at 0, but here, because I'm working off of I'm going up to 8, I'm going to not center it quite at 0, right? 8 is greater than 3 because 8 is further to the right. We can do that with any integers. I'll do a couple more examples. Just keep coming back to your number line anytime you're asked to figure out when one number is greater than another until the intuition hits, because this is how mathematicians decide what is greater than. But you could use the words to just mean whatever number is like the number itself is bigger. So we need to have that consistent definition. We have to all agree each time we say greater than, we simply mean it's farther to the right on the number line. 3 is greater than -8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, because 3 is further to the right. It doesn't matter that the 8 part of the -8 is a bigger number, right? It's just if it's farther to the right, it's going to be bigger. Further, farther, I never know which one is the... let's see, another example. Which is bigger, -8 or -3? -3. Even though they're both negative and 8 is a larger number, nevertheless, -3 is greater than -8 because even though they're both negative numbers, 1, 2, 3, 4, 5, 6, 7, 8, 2, 3, -3 is farther to the right. When in doubt, put it on a number line. Change it from the symbols to the picture. And I guarantee if you draw your number line and you count your distance, whether it's positive or negative, and you mark your two numbers down, and then you just ask yourself which one of these numbers is farther to the right, you'll be able to get it right 95% of the time, because everybody makes mistakes. Okay, so these are our pictures. These are great. I really, really encourage you using the number line. But let's talk about symbols for greater than. So let's see, 8 is greater than 3. This is words. And I'm going to do the number line again. Here's the 8. So this is pictures. And if I want symbols, there's a couple of ways I can do this. If I go from let's go from the picture first. I just write down the two numbers that I care about, the 3 and the 8. And then I use what's called an inequality symbol. It's called an angle bracket. You can find it on your keyboard above the comma. And it opens toward the larger number. I go through this in a lot of detail because I think everybody can kind of say, well, yeah, I know 8 is greater than 3. I know 3 is greater than -8. I could put it on a number line. But these particular symbols that we choose to use, they can get a little confusing because you can write it in different orders. And sometimes you have to put a little line underneath. And what does that mean? And so I like to go through it in detail because picking the wrong symbol can make it seem like you didn't understand the math. And I want you to get the symbols right, mostly so you have that confidence about the math. But I also want you to know if you get the symbols wrong, that doesn't mean you don't understand the math. That's because these particular symbols are a little weird. If you want help remembering, right, this little monster, and the monster likes the bigger number. The monster eats the larger number. That's up to you. Eight is greater than 3. We agree that's true. Would we agree that therefore 3 is less than 8? Yeah, right. We're saying it in a different way. It has the exact same meaning. If we wanted to be fancy about it, we could say these are in the same fact family. Exact same meaning. Because 3 is less than 8 means 3 is left of 8 on the number line. Here's my symbols again. 3, and then the symbol, and then the 8. can be read as 3 is less than 8, or 8 is greater than 3. Oops. Starting to get into, can't see it territory. There we go. And so I can also turn the symbol around, and if I put the 8 first, I just make sure the symbol still opens towards the 8. Right? 3 is less than 8 is equivalent to 8 is greater than 3. I can read either of these symbols with either of those sentences because they're all equally true. If I build it from a number line, I'm probably going to pick the 3 and then this symbol here and then the 8. And one of the difficult things is I had a great conversation with my wife about this because she's great at math, but she's not a mathematician. And she said, that's the less than symbol. And I said, well, it depends. And we were actually talking about it because we were at a restaurant and they were advertising NA beer, and they had this symbol and then 0.5%, which, or no, it was this symbol and 0.5%. Because if you read it, right, it depends on how you read it. Anyway, it's super confusing, is what I'm trying to say. So the symbol that you pick, it changes its meaning depending on which way it's facing and depending which numbers are on either side. So building it off a number line each time until you really get comfortable with it is pretty important. I would read this normally 3 is less than 8 because the number 3 comes first, which is equivalent to 8 is greater than 3 because the 8 comes first. But I could read these either way. Okay. So I can't really tell you have a greater than symbol and a less than symbol because it depends on the numbers to either side of it. I think we'll come back to the other types of inequalities later. So how would you write, let's see. Okay, let's compare -2 and 7. Which one of these numbers is greater? 7, and why is that? Because it's to the right. It has nothing to do with the size of the number just by itself. It happens that 7 is also a larger number than 2, but the key is that 7 is to the right on the number line from your perspective. So I could write this as the -2 first and the 7 later. Which way would that symbol open? Toward which number? It would open towards the 7 because the 7 is greater than -2. But I would probably read this as -2 is less than 7, just because people in English tend to read left to right. Now in Arabic, actually, you might read this, I don't know the words in Arabic, but I might actually read this as 7 is greater than -2 because Arabic reads the other direction, right to left. And if I had the 7 and then the -2, which way would the symbol open? Towards the 7, right? So we don't care so much about opens to the right, opens to the left. It opens towards the greater number, towards the larger number. And I would read this as 7 is greater than -2. On your worksheet, you have a couple opportunities to work with this. I'm going to encourage you to write the words as well. All right, and maybe write them in both ways, just to get used to all those different ways of saying these equivalent things. And by the way, this is one reason why pictures is nice. There's only one picture, right? It's draw your number line, the 7 goes here, the -2 goes here. It's very clear that 7 is farther to the right. There's no which way does a symbol go, which word do I use, less or greater. Moving on. the idea of absolute value. Absolute value in general is the size of the number disregarding or not caring about any negative signs. Disregarding, not caring about any negative signs. What is the size of the number 8? 8, yeah. What is the size of the number -5? 5, because I don't care about any minus signs. I'm just looking at what's its size. Again, the picture approach, I think, is a great way to get an understanding for absolute value. Let's do the size of 8 first. Sometimes it really helps to watch math like a video instead of like a picture. So get those last couple notes prepped and then watch the screen. I'm going to do the size of 8. Nope, still get notes. That's cool. Sometimes I go real fast. On the video, people can just pause it, but you all can't pause. Well, you are kind of pausing me. So if you're on the video, take a coffee break or something. All right. I always want you to have enough time to write the notes down. So if you say, slow down, I'm still writing, that's cool too. Okay, so I'm going to find the absolute value of 8. I'm going to find the size of 8. And I just do 1, 2, 3, 4, 5, 6, 7, 8. It took 8 steps to get from 0 to 8. So the absolute value of 8 is the 8 steps. The absolute value is the number of steps it takes to get there from 0, not caring which direction you go. The absolute value of a number is the number of steps it takes to get from 0 to that number, not caring about the direction. Let's look at the absolute value of -5. And we're going to use the pictures as well. The absolute value of -5, I'm going to start by drawing a number line. I'll stick my 0 somewhere in the middle. -5, is that to the right of the 0 or to the left of the 0? It's to the left. So we're going to be taking our steps to the left. So do that. Take your however many steps it takes to get there. This time going to the left. 1, 2, 3, 4, 5. Okay, it took 5 steps. So the absolute value of -5 is 5. This is actually a super important concept. And it kind of, it's what takes negative numbers from being imaginary to making them real. Right? If I have, I'll use it slightly different numbers. If I have 4 cows, but I owe you 7, it's kind of like I have -3 cows. But really, it's I have my 4 cows that belong to you and some other 3 cows that will go to you once I get them. I mean, those aren't negative cows, really, right? They're just cows that I don't own that I have to give to you. So that 3 cows I owe to you, there's still 3 cows. That's the absolute value idea. They're not negative cows. If we think about speed, whether I'm running that way or running that way, so whether I'm running to my right or running to my left, I'm still running at a positive speed. I'm not running at a negative speed. So I focused on the words and the pictures, but there is symbols notation. The symbols for absolute values are vertical lines on either side of the number. Actually, it's either side of whatever is inside the absolute value, but right now we're working with numbers. So absolute value of 8, I put vertical lines. Absolute value of 8 is the number of steps it gets from 0 to 8. And what is that number of steps? 8. There we go. Absolute value of 8 equals 8. Absolute value of -5 is the number of steps it takes to get from 0 to -5. How many steps? 5. Be careful that your absolute value symbol doesn't look like how you write the number 1. I always make my absolute value symbols kind of a little bit exaggerated. Make sure that they're both taller and shorter than whatever, or above and below whatever is in there. What's the absolute value of 11? Right? It can be a disaster. Some of you may do your ones with the little flag at the top or the little thing at the base, and that helps, right? So don't do that. Do absolute value of 11. And even that's really confusing. Mathematicians and their bad symbols. You're going to see it, so I need to show you. Fortunately, when things are printed, and borrow your book again. Things are printed, most printing makes it a little more obvious. Here's the absolute value symbol. That's pretty obviously not a 1 on either side of it, but you're going to be doing a lot of work by hand. So just keep in mind. Okay. Last topic from this section is opposites versus negatives. I'm actually going to start with negatives. Let me see how do I want to say it. I'm just going to start on it. Switch it, right? Negative versus opposite, even though in the book it's opposite versus negative. The word negative means the number is left of 0 on the number line. Negative is just a descriptor. It's a description of a number. -3 is 3 steps left of 0. The word opposite means, I'm going to sneeze here. Thank you. Thank you. The word opposite means change the plus symbol to a minus symbol. Or vice versa. Opposite is an action applied to a number. The opposite of 3 is what? -3, because I changed the +3 to a -3. We don't write the plus, but if nothing's there, we assume it's a plus. The opposite of -4 is 4, because I changed the symbol from a minus to a plus. Opposite is doing something to your number. Negative is just that group of numbers that are all to the left of 0. However, in math, the minus sign is often used to indicate opposite. So if I want to say the opposite of -4 is 4, often what I'll do is I'll take the -4 or the -4, and I stick it in parentheses and I put another negative out front. The negative of a negative is positive. That's how I might read it, but really what I'm saying is the opposite of a negative is positive. I just kind of want to let you know what we're talking about here when we say opposites versus negatives. A negative is just the number itself. -3 is 3 steps left of 0. It's a property of that number. The opposite of 3 is saying take the +3 and then stick a minus in front, and you get a negative. We change the sign of it. All right, that wraps up section 2.1. I'm going to stop the video and make a new one. Yes, you have a question before we go on.
Yeah, so I did the 2.1 and I mean, I was